So John Watson's quote about making a child anything he wanted to just by changing their environment was a denial of nativism. It was saying that there were no predisposed abilities in babies and the baby came to the world as a blank slate. Linguists started to particularly have a strong objection against that idea. And Steven Pinker was one of them. And he wrote the book, The Blank Slate, The Modern Denial of Human Nature, basically arguing that no, actually babies do come to the world pre-equipped. And because of that, they're actually able to, for example, learn languages. So Skinner and others within linguistics actually pulled the brakes on behaviorism and really started to criticize it for a variety of reasons. So that gets us to the field of linguistics. Let's just think about this for a second by looking at the following sentences. Red tape holds up new bridge. Now, you can pause there for a second and think, wow, they're holding up a whole bridge with tape? And quickly you'll realize, now actually this is a saying, red tape holding up something, meaning there's some bureaucracy stopping a new bridge from being built. So it's not literally red tape, but figuratively, we can start to understand what's going on. Same in the next sentence. Pittsburgh seeks a mayor with stomach for belt tightening. This does not have any relationship to the size of the stomach of the mayor, but instead has to do with pulling the strings on some of the budgets. Right? So it's not literal. It's a way of expressing some more abstract idea. Safety experts say school bus passengers should be belted. There too, the language is ambiguous. You might think, wow, the school bus driver needs to start hitting all the passengers. Then you realize, now actually they mean put your seatbelts on. The arsonist had a burning desire. You realize they're not literally talking about having a burning desire, but actually had a desire to burn stuff. The florist sent the flowers, was happy. There you can see the grammatical construction can first throw you off, because they then realize that the flowers were actually sent to the florist, and the florist was happy about it. Sprinklers contain fire. Again, it's not that sprinklers have fire within them, but no, we use them to actually contain the fire. So, why am I going through this? Well, linguists pointed out a lot of our linguistic structures are actually so ambiguous that purely based on behaviorism, of some sort of pairing between some stimulus and response or some rules that you've learned, it's very, very difficult to actually account for any of these sentences and our ability to understand them. So they raised this as an issue and said, well, there has to be some sort of representation involved because otherwise people would never be able to understand language at many different levels. Main person behind this movement was really Noam Chomsky. And Noam Chomsky these days is more known as an intellectual who has a lot of opinions about a lot of international politics, a very interesting human being, very smart guy. But he actually started off as a linguist. He was a very famous linguist at MIT. And basically his main point was that behaviorism could not account for the flexibility as well as the generative nature of language. Generative meaning we can just come up with it on the fly. You actually have been listening to me speaking and producing generative language. I didn't write this out. I don't have a piece of paper in front of me with all these words, word for word, in the right order. I'm just talking as I go, coming up with sentences. So that's the generative nature of language. If I could only say things that I had gotten a juice reward for, as behaviorists may claim, that wouldn't be possible because I'm just coming up with this as I go. The precise order of the words I'm using, I may have explained these concepts before, but it's hardly possible that the order is exactly the same. So how is this flexibility and this generativity accounted for by behaviorism, if I can just come up with it? So this made a strong case for mental representations. And there's a couple more ideas here, a couple more sentences. Here's a famous sentence: colorless green ideas sleep furiously. It's a nonsense sentence, but you can almost feel in your head that you're coming up with some sort of mental image for it. So this was the linguist's counter argument against behaviorism being able to account for all human behavior. That really set one step towards the start of the field of cognitive psychology. The other one was computer science. So Chomsky was making these arguments in the late 60s, early 70s. And at that time, too, within computer science, there was massive revolution happening. Here you can see a picture of one of the first computers. And this computer has way less computing power than any of your cell phones has nowadays. But this was one of the first computers. A computer is basically an information processing system. It takes some sort of input from a keyboard. It then does a bunch of processing on it. It may figure out that it's a word, and then it throws something on the screen, or it does something in response depending on what it's been programmed for. People started thinking of computers as an analogy for the human mind. And this came right along the same time as Chomsky making the arguments against behaviorism. And that was meaningful and important because it meant that we needed a different idea, a different way of thinking about the mind. Not in terms of just trained responses based on rewards and punishment, but an idea that maybe the mind is like a massive computer. Relies on representations and mental processes. So if you look at a computer again, there's some sort of input, a mouse or a keyboard. You do something on that gives input to the memory system, central processing unit. It might query some long-term storage, the hard drive. A bunch of processing happens, and then there's some sort of output. Maybe either a sound, a song that starts playing, or some output on the screen, and so forth. So people started thinking of this type of system as a possible analogy to the human mind and brain. So input comes from our senses. We get sensory input from our eyes, our ears, our touch, our taste, and so forth. All of that input gets sent to some sort of central processing, meaning our actual mind. There's memory going on. There's a bunch of processing that happens, and then ultimately there's some sort of output. We either decide to make an action, pick something up, say something, and so forth. So this is basically thinking of the brain and the mind as some sort of representation, some sort of simulation of what that might look like based on a computer model. Right? So you're trying to almost simulate these blocks on a computer, just like we could simulate on a computer what our actual neural circuitry in our brain may look like. Now, this idea has obviously raised a lot of questions for a long time, and there's of course been the question around for a long time whether machines can ultimately actually think or not. And you can take a course in philosophy on just that question, whether machines can think or not. So I'm not going to give you a straightforward answer here, but I definitely need to raise the question because it's important. You can talk about this on the discussion forum amongst yourself. It's interesting to see what people's opinions are. Some of you might have very developed opinions about this issue, right? Do you ultimately think that we can create computers, machines in a way that are basically the same as human beings? And, would they be able to think or not? One problem you may run into as you have that discussion is, well, what should qualify as sort of the standard of what we call thinking? This has been a question that has been asked for a long time, and a very smart human being by the name of Alan Turing actually developed some ways of thinking about this question. So Alan Turing was a British mathematician and computer scientist, and his life story is very sad, and I'll tell you that in a minute, but he was confronted with the question, when can we say that a computer can think versus when do we say, no, actually a computer can compute things, but it cannot actually think? Well, the test Turing developed was sort of a hypothetical mind experiment where basically the test was as follows. Let's imagine that you put one human being in a room, and that human being is going to interact with somebody in another room that they can't see. And that other entity is either another human being or it's a computer. Now, the person in the first room, let's just imagine it's you, and we've all had this experience. Sometimes when you're on a phone system, you're not entirely sure if you're talking to an actual person or to some sort of recorded system. That's basically the Turing test. Okay? Turing said that we should consider computers to have intelligence if a human being can't actually successfully determine anymore whether they are interacting with another human being or whether they're interacting with a computer. If that's a 50-50, they're just not sure, then that would pass the Turing test, and the machine at that point would be sort of considered to have the equivalent of human intelligence. Now, I said before, Alan Turing's life story is actually extremely sad, unfortunately. First of all, if you want to know more about Alan Turing, I recommend that you watch the movie called The Imitation Game that came out a couple of years ago. Benedict Cumberbatch is in it. It's a great movie, and it actually really does justice to Alan Turing and his contributions, and as well the struggles that he faced. So first of all, his tremendous contribution to mankind was that he actually managed, as a computer scientist, to crack the Enigma code, which was a code that the Nazis used in order to communicate with one another. By Turing cracking that code, it gave the British soldiers and the British army insights into what the Germans were up to, and the estimate is that by doing so, the war actually ended several months earlier than it would have had it not for being that Alan Turing cracked that code. So it would have led to many millions more dead people, and Alan Turing saved that. So that's his tremendous contribution to mankind. The other tremendous contribution is that from cracking that code, that actually gave rise to the start of computing. And Alan Turing, by many, is actually credited for being the founder of computer science and for really taking the first steps towards what a computer even is. The unbelievably tragic and sad part of Alan Turing's life is that Alan Turing was gay. At the time, even in 1952, when he was convicted of this was still a crime punishable by chemical castration in Britain. So here you have this tremendous scientist, this unbelievably sharp mind, who is only in his early 40s at the time. And he's being forced to undergo hormone treatments in order to make his gayness go away. Turing became depressed from this, deeply probably disappointed in mankind, and ultimately at 42 years of age ended up taking his own life. So, very sad. He has been pardoned finally by the Royal Crown only several years ago, but the story of Alan Turing is just, it's filled with unbelievable amazement and brilliance, and then with absolute sadness when it comes to the way he was actually treated in society later on. So that's Alan Turing. Now, jump further. Computer science and linguistics, I already said, they gave rise to this rejection of behaviorism and provided an alternative model of the mind by thinking of the mind as a computer. And that's really the start of cognitive psychology in the 1970s. Cognitive psychology at its core initially really thought of the mind as a computer, and it used an approach that's called the information processing approach that basically deals with the storage, meaning memory, the manipulation, meaning thinking and problem solving, and the transformation of information. So what this means, the transformation of information, is really a way of talking about perception, for example. Stimulus comes into the system, and as I already said, that could be a visual input, it can be a sound, it can be touch. Attention is paid, then there's perception, that perceptual processes work on it. Those perceptual processes give rise to thought processes. Those thought processes then lead to some sort of decision, and then ultimately there's some sort of response or some sort of action. And the idea here is that this structure is very similar to how a computer processes information. So the goal of this approach is to specify each of these processes and structures that are involved in cognition, and then the idea is that the mind actually resembles at some level that of a computer. I'll start talking about how this then leads to how we study the mind in the next video.